Okay, so where we ran out of time was on number 34. We had the R1, we were given the R1 was 12 ohms and the I1 was 3.2 amps, and that the I2 was 4.8 amps, and they wanted to know R2. So our first step was to find V1 by doing I1 R1, and once we found that, 38.4 volts, that was our V2 and our V total. So now we can find our R2 by doing V2 divided by I2. So the 38.4 volts divided by that 4.8 amps that they gave us. And when we do this, we get an R2 of 8 ohms. Okay? Then the question wants to know what's R total, so you could do 1 over R total is equal to 1 over R1 plus 1 over R2, which is 1 over 12 ohms plus 1 over 8 ohms. Common denominator would be 24. So 2 over 24 ohms plus 3 over 24 ohms is equal to 5 over 24 ohms. So R total is equal to 24 ohms divided by 5. So R total is equal to 4.8 ohms. Your other option would be you could have done R total is equal to V total over I total. And V total is the same as the other V's, 38.4, and I total, you could add these up and you would get 8 amps. And lo and behold, you get 4.8 ohms again. So it does not matter which way you do this. But don't think you can always avoid the fractions. You can't. I'll make sure of that. All right, number 35 says a current of 4.8 amps leaves the power supply. So that's my I total. And separates into 3 currents running through 3 parallel loads. The current in the first one is 2.5 amps, so I1 is 2.5 amps. The current through the second one is 1.8 amps, so I2, 1.8 amps. And the current and the resistance of the third one is 108, so R3, 108 ohms. Calculate the equivalent resistance, Okay, so sometimes it might look like you don't have enough information, okay? And we're going to move today, once we go over this one, into complex circuits, compound circuits. And one of our very good friends are going to become tables. So I want to show you how you can solve with a table. So the first thing you do is you create a table for you create a column for every resistor. So for the total, for the 1, for the 2, and the 3. And we always go VIR, go down, okay? VIR, so V total. And then we fill in what we know. And so we know I total is 4.8 amps. We know I1 is 2.5 amps. We know I2 is 1.8 amps. And we know R3 is 108 ohms. Okay, and how the table helps us is that it's like a Sudoku puzzle. Whenever you have only one thing that you don't know in a column or a row, it means you can find it. So we can find I3 because in parallel the I's add up. So 4.8 minus 1.8 is 3, minus 2.5 is 0.5. I3 must be 0.5 of an amp. Now that I have my I3 and I have my R3, I can find my V3 because it's the only thing missing in this column. V equals IR. This should be 54 volts. Once I find my 54 volts, I realize that this is a parallel circuit, and in parallel, all the voltages are the same. So 54 volts, 54 volts, 54 volts. And now I can find my R's. 1.8 into 54, I can't do that in my head. And I, shoot, wait, I do have a calculator. I was going to say, and I don't have a calculator anywhere near me. 54 divided by 1.8, 30. Oh, I should have been able to do that in my head. 9 would have gone into each. Shoot. 30 ohms. 54 divided by 2.5, 21.6. And 54 divided by 4.8, 6 goes into both of those, 9 over 8. 11.25 ohms. And we're done. So the chart can make our lives easier. All right? So stay tuned. We'll be using the chart in today's lessons with complex circuits.